What is a chi-square goodness of fit test? When do we perform this test and how to perform this hypothesis test? In this video, we will try to understand that. The chi-square goodness of fit test is a non-parametric hypothesis test. This test is used to determine whether a variable is likely to follow a specified distribution. Let's say we have counts of values of a categorical variable and we also have expected numbers for the counts. For example, let's say we throw a die 60 times. So we can get 1, 2, 3, 4, 5 or 6 in each throw. So the categorical variable here can have 6 values, 1 to 6. Let's say we have the counts of the number of times 1, 2, 3, 4, 5 or 6 appear. Let's assume the numbers on the die appear this many times. Now, if the die is fair, all the numbers from 1 to 6 are equally likely. So, we should gauge each number 60 by 6, that is 10 times. We can see a difference between the expected values and the obtained values. But is the difference statistically significant? In other words, we want to know whether the categorical variable indeed follows a specific distribution, a discrete uniform distribution in our case, or whether the observed difference arises by chance only. To know that, we can perform a chi-square goodness of fit test. So, our null hypothesis is that the die is unbiased and the difference between the expected values and the observed values is by chance. And the alternative hypothesis is that the die is biased. Let's also assume that the level of significance is 0.05 in our case. So, let's try to test our hypothesis. In the chi-square goodness of fit test, the test statistic is calculated using the following formula. Chi-square is equal to summation from I is equal to 1 to n OI minus EI whole square divided by EI, where n is the number of categories of the categorical variable, that is 6 in our case. Now, in our case, the expected value or EI is equal to 60 by 6, that is 10, for all I between 1 and 6, as all the numbers are equally likely on a fair die. And OI is the observed value of the number of times a number appears on the die. So, let's look back at the table. At this point, if we add the values OI minus EI, they will cancel out each other. So, we will square the numbers OI minus EI and then sum them. So, our test statistic is chi-square is equal to 6.4 after calculation. Please note that this test statistic follows the chi-square distribution as shown in the graph, and the shape of the chi-square distribution graph depends on the degrees of freedom. So, we will look at the chi-square table to find out the critical value for a particular degrees of freedom. Please note that there are 6 categories for the categorical variable in our case. So, the degrees of freedom in our case is 6 minus 1, that is equal to 5. Here is a chi-square distribution table. We will look at row 5 and column 0.05. We get the value 11.07. So, our chi-square value is 6.4, which is less than the critical value of 11.07. So, we fail to reject the null hypothesis. Hence, the difference between the observed values and the expected values is not statistically significant. Please note that the chi-square goodness of fit test should follow certain assumptions. They are: we need to take random samples from the population. We need to perform the chi-square goodness of fit test on categorical or nominal data. A minimum of 5 observations is expected for data categories. I hope this helps. Interested viewers who want to know more, please visit the website of the Security Buddy or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.